Our next paper is called Networked VR System, Kitchen Layout Design for Customers by Tomohiro Fukuda, Ryuichiro Nagahama, and Junji Nomura, all from the Matsushita Electric Works Limited. Tomohiro Fukuda is a member of the research staff at the Virtual System R&D Group of Matsushita Electric Works. He's engaged in research in computer graphics, VR, and internet working technologies. He received his BS and MS degrees in environmental engineering from Osaka and also majored in computer-aided architectural design at Osaka.
Good morning, everyone. My name is Tomohiro Fukuda of Matsushita Electric Works, Japan. What I am presenting today is one of our new VR technology applications. The first is that how we put a VR system to practical use in the kitchen layout design process. One of our strongest product lines is the system kitchen, a custom planned and built kitchen combining cabinets and appliance units such as sinks, gas ranges, and dish dryers. Our VR system helps our customers to make decisions when designing the layout of their new kitchen. The second is about our VR systems. Since 1991, we have developed the systems and been in practical use. We explain these features. The third is that we extend the VR system to be accessed on the internet and to correspond to the changing needs and values of the consumer. The fourth is developing the new system for customers. The system is based on W3 and VRML technologies, and we've added many scripts to W3 and VRML. The fifth is conclusion remarks. We succeed in adding many scripts so that customers can design with parts interactively. In the future, it is a very important problem to design so that some idea is needed in the case of PC. The first is that how we put our VR system to practical use in kitchen layout design process. Here by the word design, I don't mean the design of detailed parts of each unit, but the arrangement of the units. When an interested customer comes to the showroom, a person we call the kitchen planner first explains the kitchen product's description using catalogs and displays. Next, using pencil and paper, the kitchen planner draws a rough layout according to the customer's wishes. Then a floor plan, an elevation view, a perspective drawing, and a written estimate are created on a CAD system, which named is Matisse, based on the rough sketch. Matisse database includes approximately 30,000 of Matsushita's kitchen products, as well as data on customers' kitchen designs. At this early design stage, customers can see a floor plan, an elevation view, and a perspective drawing. Now, if the customer were to actually construct the kitchen at this stage, there might be discrepancies between the system kitchen actually manufactured and the customer's original idea. Our VR system helps to eliminate these mistakes. Customers can have a clear concept of their potential purchase and also take part in the design process of the product through a VR experience. Final approval and appearance drawings are made, and the other is sent to the computer integrated manufacturing lines. Next, we explain our existing VR systems. We have already developed our VR systems named Viva and Keeps, which is next version of Viva, and have been in practical use in our showroom from 1991. Viva is one of the first application systems in the industrial field which employed virtual reality technology. Although the VR system interfaced properly with our conventional kitchen CAD system, the hardware of the VR system was not adopted for nationwide showrooms. Keeps is next version of Viva and classified in two systems. One is developed on GWS and based on the division's DVS. It features high quality and high performance. The other is developed on PC and based on Sense8 Corporation's World 2 kit. It made it possible to achieve hardware cost reduction and has been in practical use in our 4 showrooms since October in 1994. More than 100 customers experience a VR system every month. This is a scene of VR experience in our showroom. A customer put on a head-mounted display and 3D mouse, and the other customers can share with the large cylindrical screen and 3D glasses from the same viewpoint at the same time. Now we extend the VR system to be accessed on the internet and to correspond to the changing needs and values of consumer. Keeps is based on local area network and used only in the showroom. We cannot reduce time and place restriction and correspond to the changing needs and values of consumer. Corresponding to the changing needs and values, customers will be able to design the layout of their new kitchen by themselves at home and have clear design images before they come to the showroom. At present, Keeps is classified in two systems. One is developed on GWS and based on DVS. The other is developed on PC and based on the Sense8 Corporation's World 2 kit. We convert Matisse data format to the data format of each VR system. Each data format, DVS and WTK, is a local language which is RAM-based and machine and software dependent. We need the new system based on a universal language which is low cost, internet-based, and machine and software independent. Recent progress in personal computer and network technology makes it possible to realize this design system. Especially, the methodic development of the VRML is one of the most important standard developments in 3D graphics and internet working. As an informal, intense, open, and collaborative design process has worked, the VRML, its browser, and its converter are cross-platform supported, and many of them are freeware. These features considered, it goes without saying that VRML is placed as the basic language of our new system. We concluded through the practical use for 6 years that unless it makes the representation of a reality, the system is not useful. Then we need to review reality of VRML before we develop the new system. We used a kitchen model as prototype. This model is highly precise and about 110,000 polygons. Network system considered, at present, a number of these polygons is unbelievable. But we regarded reality as most important. We checked the representation of a reality on the cross-platform such as GWS, Windows NT, and Power Macintosh. And we also checked the representation on some browsers such as Cosmoflare, Live 3D, and so on. Number 1 is the representation of the Cosmoflare on SGI. Number 2 is the Cosmoflare on Windows NT. Number 3 is the Live 3D on Windows NT. As a result, the representation and performance are very different from the platform and browser, especially GWS and PC. It is a very important problem to design so that some ideas such as polygon reduction and using proximity sensor is needed on the case of PC. Now, we developed the new system for customers. The system is based on W3 and VRML technologies and added many scripts which we need to W3 and VRML. Here are typical steps of the initial kitchen design at home. In the process 1, a customer decides the basic plan, budget, the plan of the room, kitchen layout, and included appliances will be checked. In the process 2, they select each component product and make the first plan. Cabinets, a counter, a sink, faucets, a dish dryer, a range, and a food will be selected. In the process 3, they review the first plan, exchanges and matching products, and coordinate the final plan. They change pattern of matching products. As the items to be checked in the process 1 are normally very difficult to decide for a customer who is not professional, right now our system is under development employing a genetic algorithm or an artificial life that makes kitchen design candidates and gives advice according to the customer's needs. Now, let me show you a 5-minute demonstration video. We are trying for using this system on PC, but at present, because of the bad representations on PC, we recorded this on SGI. Again, I'd like to say, it is very important to port to the PC. In this research, we suppose that a customer was given advice in this process and made preparations for kitchen layout and included appliances. The process 2 is that they select each component product and makes the first plan. The interface in the W3 appears. A customer looks right at the interface and select a door, counter, sink, and faucet interactively. If they want to know the more information, they can see by clicking the product name. The detailed information and images are shown. Each component product is selected over and over. When all products are selected, they may click the button named Start. CGI script inserts each VRML object in the interior data of VRML, which consists of interior data such as the wall, ceiling, and floor by using the inline node and makes the first plan. The doors can be opened and closed. They want to exchange the pattern of the door. A pattern palette of the door is appeared by clicking the product in the virtual world. They select a favorite pattern in the palette. It is loaded a selected door from a database on the internet so that they can review the new design. This process is continued over and over. In this example, a customer exchanges the patterns of the door and the counter. The kitchen design is much more favorite for them than the first plan. During their reviewing, if clicking this button, they go back to the previous alternative directory because the system saves the planning history. At last, we explain conclusion remarks. We realized upgrading services with using W3 and VRML technologies. Using the anchor node of VRML, the information such as the size and the price of component products can be added. We can make hyperlinks between a 3D object and a text, an image, a movie, and sound, and other 3D objects. Using the sensor or interpolator node, the function of each component product can be explained effectively. Cabinet doors can be opened and closed. Using the inline node, the necessary 3D objects can be read from other databases on the internet. Using an anchor node and CGI scripts, the design environment is ready for coordinating their own kitchen design interactively. Corresponding to the changing needs and the values, customers will be able to design the layout of their new kitchen by themselves at home and have clear design images before they come to the showroom. As the existing VR systems, Kepus is based on the local language, we need the system kitchen based on a universal language, which is low-cost, internet-based, and machine and software independence. Then we place VRML as a basic language of our new system. Both W3 and VRML are raw technologies, so that we combine and add many scripts to W3 and VRML as necessary. Our new system was developed on cross-platform supported and make it possible to put our VR system on the internet and to achieve a low cost. This system is based on the internet. Of course, it uses not only at home, but at architects' offices and sales shops. In the future, we solve the problem of the expression on PC and develop much better networked VR system. It is a very important problem to design so that some ideas is needed in the case of PC. That's all. Thank you for your attention.
We can now take questions. If anyone has any questions, please come to the mics and speak slowly and clearly.
I'm interested in the data flow that goes on between the server and the browser in terms of your initial kitchen design. Are you having a CGI script generate the world file that's downloaded into the browser, and then, for example, click on a door front, make a change in the design of the door fronts? Is that generating another world file up on the browser or on the server that needs to be downloaded, or how is that?
So the question was the data from the server to the client when a CGI bin script goes. Is there an entire new VRML file? How does the data flow?
Data flow?
Yeah.
That's all right. not reply.
Do you want to either try and rephrase that a little bit more simply, or?
Okay. When you start with an initial, okay, the user starts making choices. They select the faucet type.
Chooses.
They select the faucet, the cabinet front, the sink type, whatever. They make their choices. It looks like using regular form-based HTML. And I assume that information is transmitted back to the server, and a CGI bin script generates a URL file from that it's downloaded to a browser. That's my supposition, but I don't know.
So the question is, they pick something with an HTML form, and then a CGI bin script runs, creates a new VRML file. Is this what happens, or does something else happen when they make a choice?
Something else.
Can you say what happens?
Something else happen.
Okay.
Yes. Sorry. We discuss in person later.
Thank you.
Sorry.
All right, let's try to take that question offline. Are there any other questions? All right, great. Oh, one more.
You said your models had 110,000 polygons. Have you considered using fewer polygons, and what problems have you run into with using fewer polygons, smaller number of polygons?
So the original models were very big. Did you use polygon reduction in how many polygons in those models?
Will you do that?
Yes.
And
Wait.
what problems
Yes,
did you
yes,
have
yes.
reducing?
I see. Let me translate what he said. ポリゴンカウントが10万ポリゴンぐらいあるって言いましたよね。どうしてポリゴンリダクションをしなかったのか、ポリゴンの数を減らさなかったのかという質問ですけれども。
今回
No problem. I'll translate. いいですよ、日
In
本語で。
Japanese?
Okay, fine.
今回はもう手作業で自分の手で10万ポリゴンから60,000 ポリゴンまでリデュースしました。
He reduced the polygon count from 150 to 60,000 using handcrafted. Okay. それから。
Okay. All right. Thank you very much, and thank you for the translational assistance, which I was unable to provide.